So part of the reason I cut off on the previous video was to make sure I could get a chance to check out my the actual ArrayList implementation and see how the constructor did it. And yeah, this is a simple enough explanation, which is just simply do some black magic here to create an array of E's, right? What we're doing here is we're creating a bunch of memory location slots and saying, actually these objects, they're going to be stored in an E variable, so cast it into an E array, if you don't mind, please. And Java's apparently happy with that, other than giving us a warning, right? Is there any way to deal with it? But not really. Okay, so let's go ahead and get on with the methods, because we've got ourselves a constructor. We've got ourselves a the variables we need to keep track of stuff. So what else? So now we need the methods. So let's start ourselves off on the right foot by writing something fairly easy. Public size, right? This will get the size of the array. This will return the size of the array list. How many items are in the array list? Well, that's equal to the size. Now you might be tempted to so first off, what's the type of that? Well, it's the number of things in there, so that would be an int. All right. Now you might be tempted to return the data.length, right? But that's actually going to be, that actually is the capacity of the list. That's how many things we can put into the list, not how many things are currently in it. So size is the number of things, and we use size rather than get size because that's what the collection says to do. That's what we get from list, and list gets that from collection. All right. We can also implement a fairly another easy method that I haven't gone over because it's easy enough just to do here. Boolean is empty. This returns true if it's empty and false if it's not. In other words, if there are no items in this, right, the size is equal to 0, not the capacity. If the size is equal to 0, return true. Otherwise, we're going to return false. Of course, we can simplify this easier, right? We don't need the else here, right? If we don't return true, we're just going to return false. But we can actually simplify this further, because if this size is equal to true, if this size is equal to 0, evaluates the true. If expression evaluates the true, we're returning true. If it's empty, we return true. Otherwise, we return false. So in other words, if this is true, we return true. If it's false, we're returning false. So we could just instead return the statement itself. The textbook used in 1068 referred to this as Boolean Zen. So return size equals 0, right? Put some parentheses around there if you want to feel better about it, right? This will evaluate to true or false, and so we return that. All right, so those are the easy ones. Now let's go ahead and start up with the, we might as well get started, with our actual bit of work with actually dealing with how do we deal with adding an item to the list. We're going to leave how do we expand the list to later, right? How do we increase these capacity for later, for just a bit later, all right? But for right now, we need to figure out what we're going to do when we add an item to the list, right? There were two add methods, public Boolean add E item, right? And this will take the item and we're going to add it to the end of the list, and we're going to just return. And it will return true or false. It's going to return true to say it's successfully added. I'm putting return false there to say that it's not implemented yet. I'm going to come back to that one. The other add method is public void add int index E item. Right? And this says I want to add some item at a specific index to this array list. All right? So first thing, okay. This one seems less complicated because there's less options that can happen. So we're gonna do it. So we're gonna do it last. Actually, that seems silly, but actually doing the harder one first means that actually we only have to do the work once as opposed to twice. Okay, so this is actually fairly straightforward if you to do. The first thing we want to do is check to make sure index is in bounds, right? So if, and this is something you'll do in the linked list as well. So if, so we want to make sure that index is valid index. So first off, if index is less than 0, we kind of know automatically that that's just not going to be good, right? It's not going to work out if it's less than 0. But it's also possible to be out of bounds in the other way, right? So let's go ahead and draw something. So I'm going to adapt my amazing MS Paint skills, but we're going to use it on Linux on a program I've never used before, right? So, okay, Pinta. So you'll just have to bear with me. Oop, that works just as I thought. Yep, terrible MS Paint skills to the rescue. Okay, so let's go ahead and I'm going to add, and I've got A, right, B, X, because you thought I was going to put C there. I'm keeping you on your toes. And Q, because the contents actually don't matter for this. We just need to fill up space, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all right. Suppose this is our array list, right? We've got 4 slots open up. What indices are there? Are they? We've got 0, 1, 2, 3. Okay. So these are indices, right, for the items in the array list. Okay. The underlying the data array, right, is A, B, X, Q, and then a bunch of nulls. Okay. Right. So the question is, what are so let's go ahead and also just define this. What is the size of this? The size, right, is 4. Right? The size of this array list is 4, right? Even though there's more slots we could add. So what indices could I validly put could I validly put something in, right? I could add like Z to index 0, right? And that would push A to be index 1, B to index 2, X to index 3, Q to index 4, right? Could put that there. Or I could put the Z over here, right? And A and B would stay in the same place, but that would move X over to 3 and Q over to 4. I'm not asking how to do it yet. That's next. Right now I'm just trying to figure out where can I put this Z, right? I could also add it over here, right? I could add it right over here. Wouldn't have to push anything over at all, right? I could add it also over here and just have to push over Q, right? Right, what I would have to do is, let's see, right, if I were to add Z here, it would take that. Oh, that did not work the way I wanted it to do. So it would take Q, and can I drag you? Hey, I can drag you. And then I could put Z right over here. All right. Fair enough. So what are the valid indices? I could do an add Z to index 0, index 1, index 2, index 3, or index 4. Index 5, though, would give me an out of bounds. Anything beyond 5 would give me an out of bounds. So putting it at 4 is fine. What's the significance of 4 here? Well, 4 is the size of our array. Sorry, of our array list. So long as that, so from the theoretical standpoint, right? So long as I've got my index is either 0 through the size -1 or size, that's a safe place to add it. It's not going to create any gaps. So those are the valid indices I can add it at. So if the index is that, or if it's greater than the size, it's invalid, right? Makes sense over there, right? If I try to add something over here, if I try to add our item here, not going to work. Here, it's not going to work. Here, it's not going to work. Adding this item over here will work. Adding this item over here will work. It will just push X and Q over, so Q will be at index 4. Right? So essentially, I'm allowed to add, if the index is anything below the size or the size, it's perfectly fine. Right? And you could reverse this if you wanted to. You could reverse the range if index is greater than or equal to 0 and less than or equal to size, making sure it's in bounds, right? That's a totally different way we could write that. We could totally write it like this. If index is greater than or equal to 0 and index is less than or equal to size, right? So long as it's one of those things, then that's, you know, if it's out of that bounds, right? If it's out of that bounds, hence the not, then that's an issue, right? So here we're just checking to make sure if it's less than 0, obviously that's no good. And if it's greater than size, well, it's going to be over here. And we don't want that. Hopefully that makes sense to everybody. If you need me to explain it to you more, please send me an email. So return. So in this case, we need to just say it's not going to work. We're going to do that by creating an exception, which is something you may not have learned in 1068. In other words, right, those errors that you see whenever you do something wrong, we're going to be able to make them now. That's pretty cool. And the way we do that is exceptions, right? Hopefully you've messed with try-catch blocks before. If you haven't, they're like 15 minutes of content that they're not too exciting to deal with. But to create a new exception, we throw a new exception, and somebody's going to have to catch it. Not our responsibility. Index, and then we look for an appropriate exception. Index out of bounds exception sounds fantastic, right? Because the index is out of bounds. And then we can put, I think, a message here, right? We can put a message here. Index plus so let's go ahead and say, yep, index was out of bounds, and that's what's going to get returned to the user if they try to do that. I mean, we can try messing with this right now and show you that this will we can get an error. So public static void main, right? My array list of integer is equal to a new my array list of integers, right? And I'm not sure what language, what version of language they added it, but you can do type inference, right? It's not the IDE that controlled it, like I said in the previous video, or that cares. Well, the IDE might allow you to do it by default. It's kind of what I was getting at in the video. I didn't mean to imply that, but really what controls whether you can do this or not is the version of Java you're using, right? And they call this diamond notation because you're just able to put those, the less than and greater than sign, together like a diamond. And that just simply means it's going to figure out what type of generic you need just by what you put on the other side. But there's no real need. I'm going to be explicit. So my array list is equal to, right? So the only so currently the list is empty. So the only valid index to add something at is index 0. So if I try to add something to index, so if I try adding something to like index 5, right? Because it's empty, so the only valid place to put our first item is index 0. I'll try to add 0 to index, let's go, well, to be explicit, again, 100 to index 5. If I run this, I should get a, whoa, that is way too small. What's going on there? But as you can see from the red, it is an exception. Bear with me for a sec. You might want to fast forward. Console. Console font. Use console font instead of, okay. Size 4. What? 20. Apply. There we go. Okay. Welcome back. So index 5 is out of bounds, right? The entire point of this message to let the user know they were an idiot and used it something. Let's be explicit about that. Right. You know, nothing like insulting yourself when you code. So now if I run this, it will tell me that I was out of bounds. Okay. Probably shouldn't actually call the other programmers idiots, though. Even if it was meant for yourself, somebody might take that personally. So anyway, it was out of bounds. So we've got our bounds. Now let's go ahead and start by now that we know that the index is safe, let's start coding this up.